In this video, I'm going to show how I did a trace corrosion repair on an original Xbox version 1.4. Okay, I wanted to start out by showing the corrosion on the circuit board itself. It's pretty easy to see here the pitting and green oxidation that's gone on. Another patient in the sick bay. So, how do you know you got this problem? If you see the clock set screen every time you start up, automatic power on, you can't turn it off, and sometimes perhaps it powers down out of the blue. For this box, it was all the above. For this project, I used a soldering iron, solder, X-Acto knife. Actually, I used tools from my wife's clay sculpting kit, wire stripper, screwdriver with number 10, number 20, Torx heads, hot glue gun, digital multimeter, some alcohol swabs or Q-tips, some 30 gauge Kynar wire, sometimes called wrapping wire, and some painter's tape. So without further ado, alright, looking at the business end, there's 6 bolts total. You need to get to 4 under these rubber feet, and 2 more bolts are hidden under these stickers. So to get to the bolts under the feet, you just want to take the edge up, so you don't want to remove the whole rubber foot. I like to use a little oil to break the glue bond down a little bit. I use, I think, canola oil. You can use whatever, or you don't really need it. It just makes it a little easier. And then just work it a little bit and peel about 30% of it back. So it should look like this, and then just repeat for the other 3 rubber feet. So for me, my next bolt was hidden under this electrical caution symbol. My idea is just to cut a circle in the sticker and pull that off. That way it's relatively clean and easy to get to again if you need to do more mods later or what have you. Okay, my next bolt was hidden under the serial number sticker underneath this mysterious number here. I didn't have any problem destroying the number. I didn't lose any sleep, but definitely save your little disc cutout if you think that number might be of value to you later. I use a T20 Torx head to remove all 6 bolts. Pop the hood. Need to remove the IDE power and control cables from the hard drive and optical drive. Okay, next up, using the T10 Torx drive, got 3 screws that need to be removed from these brackets surrounding the drives. Once you pull the hard drive out, you can slide the power wires out of this little plastic C bracket and free up the hard drive. Well, I actually found it easier to pull the yellow wiring harness, yellow wire wiring harness, which is the optical DVD drive, power and control wires. I found it easier to pull those off after pulling the optical drive out. And now we need to pull these wiring harnesses off the motherboard. This here is the main motherboard, power supply, wiring harness, just like on any PC. There'll be wiring harnesses for the front control panel, LEDs, fan, etc. Disconnect them all. Sticking with the number 10 Torx, remove all the motherboard screws. Note these screws are the same spec as the 3 screws that were holding the disk drive brackets down, so you can just put them all in one big pile. With all the screws removed, now we can separate the motherboard from the case. Probably should have removed this earlier. Quick top view shot of the motherboard. So the main suspect in this problem is the super capacitor Microsoft chose to use to store enough charge to bridge power outages, so the clock doesn't need to be reset. Apparently, quality control issues with this supercapacitor cause electrolyte to leak out, rendering the capacitor ineffective and hazardous to the health of your motherboard. And here's our guy. So looking at the bottom of the motherboard, I observed a good bit of residue from the electrolyte leaking out as well. I could see these traces that run along the edge of the board parallel to the edge of the circuit board. Had a good bit of pitting, corrosion, and just in overall bad shape. And there's some additional traces that run perpendicular to the board that also had a good bit of corrosion and green oxidation, like you can see here. So the solution to all this is, first of all, to remove that supercapacitor, then to clean the electrolyte residue and clean the green oxidation up, and then to jump these areas where the traces are damaged. And to remove the supercapacitor, I just grab it from the top, make sure I've got the right one, and fire up the soldering iron. And then I'm going to heat up each pin that penetrates through the bottom of the board and rock the capacitor back and forth as I heat each side, and then wiggle it out. So you could just break off the supercapacitor. It's no big deal. It's just a little cleaner to do it this way. So you may also be wondering, why not replace the supercapacitor? What functionality is lost? And I came to the conclusion that this thing is only needed to bridge short power outages, and for my purposes, the power doesn't go out that much where I live, so it wasn't a big deal to me to lose that functionality. But you could replace it. It's a 2.5 volt 1 farad supercapacitor. I just chose not to. Also, if you're going to install a new dashboard or do another mod like Kodi, what have you, you can just set up NTP time client and let the network take care of the clock. Makes it all moot. I got one of those toothbrushes the international airlines give you. I decided to do a dry brushing first, knock the big chunks off before I got into the alcohol. Here I'm taking some Q-tips soaked in alcohol and cleaning real gentle along these traces, trying not to make it any worse than it already is, but get the gunk off in the process. that wasn't completely getting it, so I ended up using the toothbrush soaked in alcohol, and again gently scrubbing.
I know his name, but I just want to let you know that he's mine. No, he's mine.
We'll zoom in on this one trace here, which is just completely obliterated and will have to be jumped, and the one next to it's not so great either. More cleaning needed on the top of the motherboard where the cap was removed. I decided to reflow one side of the surface mount capacitor here because it looked pretty corroded, and add a little dab of solder to it. I'm going to jump these long traces first. I stripped about a 1/16 inch of the Kynar wire and bent it over at 90 degrees, and that seemed to work pretty good for me for kind of getting a foothold in these little vias. It's a real delicate process. You want to find a tip as you can find for your soldering iron. Also found that using a piece of wood, like I have a piece of a broken chopstick here to hold the wire in, and keep it from bouncing around too much, and you can get it pushed down as far as you need to in the via. Also, what I did is I pre-soldered the wire, put the wire in the via, then heated the whole thing, and the solder eventually flowed into the via. So after soldering one side of the jumper wires, I ended up with something like this, and labeling them J1, J2, J3, and come to find out, I had a little mistake there. The actual wiring should be like this. I had to move the J3 jumper from X to J3 there. I actually had put it all together to test it out, and I got a red ring of death, but actually everything seemed to work. It was just red. I know some people do a front panel wiring harness mod just to make the ring of death red, or to get the red halo around the eject button. So here's another way to do it. But I don't recommend it because could cause other problems, so I'm not really aware of. Anyway, this is the correct way. Note that I've chosen to jump 3 of these traces along the edge. Depending on your situation, you may have to do more, or you could possibly get away with doing fewer of those traces. Just depends on what's damaged. Okay, after wiring up the other side, I ended up with this. And here's how the other end looks up close, labeled accordingly. It's also not shown here. I used a multimeter to make sure I hadn't shorted out any traces by making my solder blobs too big, because the space between the traces can sometimes be smaller than your solder blobs, but everything checked out all right. So you can see I did use some tape in places to help hold these tiny wires in place. I'll go ahead and do the hot glue here to get everything sort of held down and insulated and ready for the next step. So other than the 3 long traces, you recall I had the 1 short trace that was completely obliterated due to that corrosion. So here I'm set up to jumper that trace, and I've got 1 end already soldered. I'll show soldering this other end here. So here again, using the multimeter to verify nothing is shorted out, and what we want open is open, what we want closed is closed. Also, in order to know where to solder the jumpers, it's just a matter of following the traces with your eyes, and in some cases it may help to use a magnifying glass or a digital microscope or something like that. The best way would be to have a known good board, and you could test out the traces that on your board are bad on the good board, and know that you need to match the continuities of the good board. So here I'm going to prep for 1 last dollop of hot glue, and I want to run the wires around those silver pads and also steer clear of the screws, obviously, but that's where the motherboard makes contact for electrical grounding with the chassis. So this is what I ended up with when I was finished. And obviously, to assemble everything back together, you just reverse the disassembly process. So to test it out, I turned it on once and set the clock. Then this is the second time turning it on. Note the power on button is needed to turn it on. Note the utter lack of a clock set window prompt. Note that the eject button works properly. Finally, note the power button powers it off. And that's how it's done.